Sometimes, it is difficult for us to explain motion in words. Therefore, we can use graphs to explain the motion of an object in detail. Linear motion graphs are used to present information and data regarding a motion. There are two types of linear motion graphs: the displacement-time graph and the velocity-time graph. The displacement against time graph is used to show the displacement of an object changing with time. This figure shows a displacement against time graph for the motion of a boy. Can you describe the motion of the boy? Line OA shows the boy moves 50 meters from the starting point with uniform speed. The gradient is positive and uniform. At line AB, the boy were at rest from the second to the 8th second. The gradient is 0. Next at line BC, the boy moves another 50 meters with uniform speed and the gradient is positive. Lastly at line CD, the velocity is negative and uniform. It shows that the boy is moving the opposite direction. He turned back 100 meters to the starting point with a uniform speed. Do note that the gradient of a displacement-time graph is actually the velocity of the moving object. The velocity against time graph allows the displacement, velocity and acceleration of an object in motion to be determined. As an example, this velocity against time graph shows the motion of a motorcycle which starts to move from point O. As you can observe, the gradient of OA is positive and uniform. This means that the velocity of the motorcycle increases uniformly. The motorcycle has a uniform acceleration. At AB, the gradient is 0. Although the motorcycle is still moving, the velocity is constant. It has 0 acceleration. At line BC, the gradient is negative and uniform. The motorcycle is moving with negative acceleration. It is also called deceleration. Lastly, at CD, the gradient is once again 0. The velocity of the motorcycle is 0. The motorcycle does not move and the acceleration is 0. What else can we determine from a velocity-time graph? Apart from knowing the motion, we can calculate displacement from this graph. The displacement is equals to the area under the graph. For example, the displacement of the motorcycle from O to A is the area of triangle OA5. The gradient of this graph is equals to acceleration. Can you calculate the acceleration of the motorcycle from O to A? Let's solve some problems from the displacement-time graph. This graph shows the movement of a toy car. What is the displacement after 4 seconds of movement? You can project the displacement from the graph. The displacement is 6 meters. What is the velocity of the car from the 3rd to the 5th seconds? First, determine the displacement. Displacement is 8 minus 4, which is 4 meters. Secondly, the time taken. Time taken is 5 minus 3, which is 2 seconds. Using the formula, velocity equals to displacement divided by time, the answer is 4 divided by 2, which is 2 meters per second. Let's solve another problem. This graph represents a movement of a motorcycle. What is the displacement after the 4th second? Once again, you can project the displacement from the graph. The displacement of the motorcycle is 15 meters. Easy, isn't it? What is the velocity of the motorcycle from the 6th to the 12th second? Firstly, determine the displacement. The displacement is 0 minus 15. Secondly, determine the time. The time is 12 minus 6. Hence we can calculate the velocity. Minus 15 divided by 6. The answer is negative 2.5 meters per second. This graph is a VTR, velocity-time graph of a ball. Calculate the displacement of the ball after the 4th second. Displacement can be calculated by determining the area below the graph. The area below the graph is 4 multiplied by 1. The displacement is 4 meters. Determine the acceleration of the ball from the 8th to the 12th second. The acceleration is the gradient of the graph. 0 minus 3 divided by 12 minus 8. This is equal to negative 0.75 meters per second. A negative acceleration is also called deceleration. This is a velocity-time graph of a moving object. What is the total displacement of this object in the time interval of 0 to 10 seconds? Remember, displacement can be calculated from the area below the graph. It is the area of the pink triangle plus the area of the green square. The area of the triangle is half multiplied by 6 multiplied by 15. This is equal to 45. The area of the green square is 4 multiplied by 15. This is equal to 60. The total is 45 plus 60, which is equal to 105 meters. Lastly, let's analyze the following situation. A toy car moves down a smooth runway, and then moves over a rough flat surface until it stops. Can you sketch the velocity-time graph which describes the motion of the toy car? As the car moves down the runway, the velocity increases. When the car hit the rough surface, it began to slow down. The velocity decreases. In another word, the car is experiencing a deceleration. That's all. Thank you for listening.